I do have a recurring dream. It has to do with exploring this endless succession of rooms that are empty and going from one to the next. And feeling hopelessly abandoned and lonely and unable to find anyone else. That's a pretty good description of death. I mean, death is supposed to be a finality, but it's actually a loss of everyone you care about. I do have fantasies sometimes about dying, about what people must feel like when they're dying, or what I would feel like if I were dying. And it's such a profoundly sad, lonely feeling that I really can't bear it. So I go back to thinking about how I'm not going to die.
Got a Secret, starring Steve Allen.
First of all, would you tell the folks your name?
My name is Raymond Kurzweil, and I'm from Queens, New York.
Queens, New York. And before we show the audience what his secret is, we have just a few seconds for Raymond to play this piece of music. Raymond, the piano's all yours.
You?
Raymond's secret concerns something that he did, and we'll start the game this time with Bess Myers.
Raymond, that's a very unlikely sounding piece of music. Did you compose it?
No, I didn't.
$20 down, 60 to go. Henry?
Was that thing written by a computer?
Wow, yes.
Well, I built a computer, and by feeding in certain relationships and music, I was able to write music with it.
Raymond, how old are you?
I'm 17.
Do your parents know what you've been up to?
My father is a musician, and he doesn't like the competition.
Raymond, I'm astounded at anyone who can do anything at all of this sort, and I predict a great future for you. We were very pleased to have you with us tonight. Congratulations.
Ray Kurzweil is here. He has been called the rightful heir to Thomas Edison. His new book is entitled The Singularity is Near, When Humans Transcend Biology.
I read your book, some of the most frightening and yet hopeful stuff I've ever read.
Ray Kurzweil is a pioneer in the field of artificial intelligence.
He's an award-winning scientist and engineer, a millionaire several times over because of his invention.
He's the holder of 24 patents.
Ray Kurzweil
Was chief inventor of the flatbed scanner.
A reading machine for the blind, Kurzweil keyboard synthesizer.
This guy is freaky. Bill Gates has called him the best in the world at predicting the future.
When Ray Kurzweil makes a prediction, lots of folks listen.
He predicted the collapse of the Soviet Union, described the rise of the internet, and foretold the year a computer would beat a chess champion.
According to Ray, you're going to have relationships with machines.
Computers will have consciousness in just 25 years.
Kurzweil sees a day when microscopic computers will make all kinds of learning as easy as downloading.
You're saying millions of tiny computers floating around in my head?
Fundamentally, you're talking about tampering with humankind.
Inventor Ray Kurzweil thinks that one day humans may be able to live forever.
We come back to this book, to the singularity is near. What does singularity mean?
When you say the singularity is coming, what does that mean exactly?
And that's what you mean by the term singularity?
What is singularity?
Singularity is a future period in which technological change will be so rapid and its impact so profound that every aspect of human life will be irreversibly transformed.
There won't be a clear distinction between humans and machines.
Our computers are not going to be these rectangular devices we put in our pocket. They're going to be inside our bodies
and brains, and we're going to be a hybrid of biological and non-biological intelligence. If you go back 500 years, not much happened in a century. Now a lot happens in 6 months. Technology feeds on itself and it gets faster and faster. In about 40 years, the pace of change is going to be so astonishingly quick that you won't be able to follow it unless you enhance your own intelligence by merging with the intelligent technology we're creating. So that's such a profound transformation that we've borrowed this metaphor from physics and call that a singularity. People routinely underestimate what's achievable in long periods of time, like 1 decade or 2 decades, because they leave out the radical implications of exponential growth. We can already sense how much more change occurs in a year than in the years before that. You speak to young people, teenagers, and even in their lifetimes, they can see how much more quickly technology moves today than it did 5 years ago. Acceleration of technology is the implication of what I call the law of accelerating returns. The nature of technological progress is exponential. If I count linearly 30 steps, 1, 2, 3, 4, 5, I get to 30. If I count exponentially, 2, 4, 8, 16, 30 steps later, I'm at 1 billion. It makes a dramatic difference. About 40 years ago, Gordon Moore saw that there was exponential growth in the power of semiconductors, of chips. Basically, every 2 years, we can put twice as many components on a chip. And because they're closer together, they run faster. And so computers get twice as capable overall for the same price every year. We'll make another billion-fold increase in price performance in the next 25 years. And again, shrink the size of these technologies 100,000-fold. So we went from a building to something that fits in your pocket in 40 years. In the next 25 years, we'll go from something that fits in your pocket to something that's the size of a blood cell. The reason that information technology grows exponentially is that we use the latest technology to create the next. So each new generation of technology grows exponentially in capability, and the speed of that process accelerates over time. This is true in general of an evolutionary process. In fact, even biological evolution, long before even humans evolved, shows the same phenomenon. The very first paradigm of biological evolution was the evolution of DNA. That took 1 billion years, but then evolution adopted it, and it's used it ever since. So the next stage, the Cambrian explosion, when all the body plans of the animals evolved, went 100 times faster. Only took 10 million years. After a few more steps, Homo sapiens, the first technology-creating species, evolved. Not only took a few 100,000 years. Evolution then shifted from biological evolution to technological evolution. It took tens of thousands of years to evolve stone tools, fire, the wheel. And then we always use the latest technology to create the next technology. So the whole pace of technology has accelerated. Major paradigm shifts like search engines evolved in just 5 or 6 years. And the reason we get to a singularity, a point of astonishingly quick change, is because it's going to go into very fast gear over the next several decades. If you ask what's the most important, most powerful phenomena in the universe, it's intelligence. All the problems that we struggle with today, people worry about the environment and energy and health and disease and poverty. We'll be able to solve those problems, in fact, well before the singularity, just through the increasing power of information technology. The cause of 80% of the disease in the world comes from polluted water. There are very inexpensive technologies emerging. I know the inventor of one such technology, Dean Kamen. Small device that can take very polluted water and create very clean water very inexpensively. For $3 billion, with this technology, we could meet all of the water needs of Africa. I didn't start with this concept that the future is going to be this remarkable change and work backwards to try to justify that. When I looked at the implication of what technology will be like and how it's going to transform our human experience in the world we live in, if you go out 20, 30, 40 years, began to realize what a significant change lay ahead of us. The three great overlapping revolutions, sometimes goes by the letter G and R. And G stands for genetics. Really, another word for it is biotechnology, is mastering the information processes in our biology. And we ultimately will actually be able to reprogram biology away from disease and from aging. N stands for nanotechnology. In the next 25 years, we will have blood cell-sized devices that go inside your body and keep you healthy from inside, that go in your brain and interact with your biological neurons and allow us to merge with non-biological intelligence. The third one goes by the letter R, which stands for robotics, robots. Really, though, refers to artificial intelligence. And that's the most significant revolution of all. In about 20 years, I've set the date 2029, a machine, an AI, will be able to match human intelligence and go beyond it. So artificial intelligence, which will give us not just more human intelligence, but will actually give us superhuman intelligence, will enable us to solve problems that we're not able to solve today. We're looking forward to a time where we can back up our brains. Our brains will be largely non-biological, so we will be basically machines. We can stop aging. We can live indefinitely. All of our biological bodies are limited, and we need to deal with overcoming their limitations with one means or another. There's nothing good about disease and death as much as we try to ennoble it. People have had no alternative but to rationalize, oh, that tragic thing, that's really a good thing. But death is a profound tragedy. It's a profound loss of relationships and knowledge and skill and meaning. Some people articulate, well, we need to accept death. That's the goal of life, is to get comfortable with death and accept it. I don't accept it. The nature of progress is exponential, and if you really think about what that's going to mean for biology, AI, nanotechnology, and the fact that all these things are going to happen simultaneously and they're all going to build on each other, the future is going to be, I think, more fantastic than anything I've articulated. There's artificial intelligence all around us. Every time you place a cell phone call, send an email, intelligent algorithms route the information. Intelligent algorithms fly and land airplanes, guide intelligent weapon systems, make billions of dollars of financial decisions every day. And there are hundreds of examples of software doing what used to be done by humans. It's narrow artificial intelligence, but the narrowness is gradually getting less narrow. And the source of how to create more intelligent systems is going to come, and is coming, from the human brain itself. Even though there's a skull around our brain, we find we can look inside, and the spatial resolution of those scanners are actually doubling every year. The amount of data we're getting is doubling every year. And we're learning that we can actually take this data and turn it into working models and simulations of brain regions. And I think it's a conservative estimate to say at this exponential pace, we're going to understand how our brains work within 20 years. We will have this toolkit of how human intelligence works. And we'll be able to create similar systems that work just as well as the human brain, or even better. Computers today already can do things that we can't begin to do. Take those advantages and apply them to the power of pattern recognition and emotional intelligence that we have, and that'll be a very powerful combination. And there's one more observation. These artificial intelligence will continue to expand, more than doubling every year. They'll continue to grow exponentially. Our biological brains are fixed. You know, a human brain has a certain amount of coherency, complexity, And when we have software programs of that complexity and coherency, particularly if they're simulations of human brains, they will seem very human. And there really won't be much difference. I mean, there's nothing in our biological bodies and brains that we won't be able to recreate and, in fact, enhance. We'll create AIs that are real people.
We will get to the point where so much of the action's going on with our non-biological intelligence, and non-biological intelligence won't just be nanobots in our brains. It'll be computation out on the worldwide mesh, the cloud computing that's already emerging now of all the different computers in the world interacting. And part of our existence will be software entities out in that cloud of computing.
If you go out to 2045, we'll be spending most of our time in virtual reality. Right now, people spend some of their time in virtual reality environments, virtual worlds like Second Life. Today, doesn't look as real as real reality, but if you look at video games and look at how we've gone from Pong up to fairly realistic renditions today, same thing will happen in these virtual reality environments.
These sort of exponential trends that Ray talks about are nowhere more visible than in a place like Second Life, where exponential growth has dominated without variation. It's interesting to see this sort of exponential growth phenomena applied to a world and realize, of course, that the virtual world is the one growing exponentially, where the real world, of course, is not.
Ultimately, this virtual reality will go inside the brain, and then we really will be full immersion with all of the senses. Virtual reality ultimately will have all of the features of real reality, plus a lot more that you can choose from millions of virtual environments. You can be someone else. You don't have to pick the same boring body every time. You can be different people in different situations. And over time, our biological bodies will become obsolete. We'll have many bodies. And we'll look back to the idea of having one body and being dependent on this one biological body and having no backup for a mind file as a very primitive time. You don't have to wonder about the singularity to see remarkable changes coming from technology. Look at today and how remarkable technology is, and it's hardly stopping. It's important to understand that these very powerful technologies ultimately become very inexpensive. These technologies start out unaffordable, but at that point they actually don't work very well. And as they work better, they also get less expensive. A computer you carry in your pocket is equivalent of a $100 million computer of a few decades ago. The tools to change the world are in everybody's hands. Today you can take an information file and turn it into a movie, a recorded album, a book. But the real promise of nanotechnology is to have a tabletop device, and you can take an information file and turn it into a physical object. You can print out a blouse. You can email someone a toaster or the toast or a module from which you can then build a house. From very inexpensive input materials, we'll create everything we need. So we are very lucky. I mean, this is the cornucopia of this explosion of information. And ultimately, information will be everything. In the future, everything will become intelligent. Nanobots will infuse all the matter around us with information. Rocks, trees, everything will become these intelligent computers. So at that point, we're going to expand out into the rest of the universe. We'll be sending basically nanotechnology infused with artificial intelligence. Swarms of those will go out into the universe and basically find other matter and energy that we can then harness to expand the overall intelligence of our human-machine civilization. So the universe will wake up. It'll become intelligent. And that will multiply our intelligence trillions of trillions fold. We can't really fully contemplate. And that's really the main reason this is called the singularity. But regardless of what you call it, it will be the universe waking up. So does God exist? Well, I would say not yet.